Hi everyone. So last week I mentioned a few times that we're going to be talking about the unit circle. So that's what we're going to be focusing on mostly this week. And in order to do so, we first need to review our special right triangles from geometry. Because really between SOHCAHTOA and special right triangles, that will help us create the entire unit circle. So there's two types of special right triangles. There's 45, 45, 90 triangles, and then also 30, 60, 90 triangles. And we call these special right triangles because anytime you have a 45, 45, 90 or 30, 60, 90, we already know the ratios of the sides. So for example, a 45, 45, 90 triangle, I know that across from the 45 degrees, I'm going to label this S and S, so for whatever the side length is. And then across from the 90-degree angle is going to be S square root 2. So whatever that side length is times the square root of 2. Then for our 30, 60, 90. So across from our 30 is our S side. Across from 60 is S square root 3. And then across from the 90 is 2 times that side. If you really don't like using S, you could always use X as well. And I'll show a few examples. So my first example here is a 30, 60, 90 triangle. Remember that angles in a triangle always add up to 180. So if I know that this is a right angle, 90 degrees, this is 30 degrees, that means that my remaining angle has to be 60. So fortunately, we are given the side across from the 30-degree angle. So remember, this is I'm going to go ahead and use X. So X side across from my 60-degree angle then is X root 3, and across from 90 degrees is 2X. So if I know that X equals 15, I can just substitute this in everywhere else. So across from that 60-degree angle must be 15 square root 3, and then across from the 90-degree angle is 2 times 15, or 30. So side B was 15 root 3, and side A was 30. Looking at another 30, 60, 90 triangle. So this time we have the side across from the 60-degree angle. Again, start by labeling your triangle first thing. So across from my 30 is my X side, across from 60 is X root 3, and across from 90 is 2X. So fortunately, if I know that X root 3 has to equal 5 root 3, the root 3's cancel out on both sides, so that means X equals 5. So that means across from my 30-degree is just 5, and then 2 times 5 gives me 10 across from the 90, or side Y. Next up, we're going to look at some 45, 45, 90 triangles. So again, first thing, I'd probably label my triangles. So across from both 45-degree angles, I have X and X. Across from my 90-degree angle is X square root 2. So I left out here because they gave me one of those sides across from the 45. So I know that X equals 5. That means that this side also equals 5. And then across from the 90-degree angle is just 5 root 2. Because I'm substituting 5 in anywhere I see an X. Okay, another example. So here again, I have a 45, 45, 90 triangle. This time they gave me the side across from the 90-degree angle, my hypotenuse. But first thing I'm going to do is label everything. So across from both 45-degree angles, I have just X and X. And then across from my 90-degree angle is X root 2. And I'm getting these labels, again, going back up to the triangles we did at the very beginning. So here I used S for a side, but you could also use X just because we're kind of used to using X as the variable. So if 13 root 2 has to equal X root 2, that means that 13 is equal to x. So both sides C and D are both 13. Okay, I have two more examples for you. So the last two are both 30, 60, 90 triangles. So in this case, I gave you the side across from the 90-degree angle. So again, first thing I'm going to do is label my triangle. So across from 30 is my x, across from 60 is x root 3, and across from the 90 is 2x. So this time I gave you that the side across from the 90 is 20. So I'm going to say, okay, well, 2x, if that equals 20, I want to find x. So I divide both sides by 2, and I get x equals 10. So then I'm just going to substitute that in on the other sides. So I know over here is equal to 10, because that's my x side, and then across from the 60-degree angle is 10 square root 3. I would prefer exact answers, and that just means leaving your answers with the radical. Okay, our last example. So this is probably going to be the most challenging one. So across from my 30-degree, as I label this, I have x. Across from the 90 is 2x. And then across from what I know to be 60 degrees is x root 3. So they gave me the side across from the 60-degree angle, my x root 3 side. Well, I know that that's equal to 12. So I'm going to need to do a little bit of algebra here to solve for x. So I am going to divide both sides by square root of 3. So I end up with x equals 12 divided by the square root of 3. However, like we talked about last week, we really do not want to see those radicals in the denominator. So I need to rationalize this. So I'm going to multiply both numerator and denominator by the square root of 3. So in the numerator, 12 times root 3 would just remain 12 root 3. In the denominator, square root of 3 times square root of 3, or square root of 3 squared, just gives me 3. And then finally, I can simplify this a little bit. So hopefully you already recognize that 12 divided by 3 is 4. So I would write this as 4 root 3. So that's x. So I need to just fill that in then where I see an x. So across from my 30-degree angle, that was the simple one, that's just x. So I know that side A is 4 root 3. And then across from my 90-degree angle, I have 2 times 4 root 3. So if I double that, that becomes 8 root 3. And that is all with our special right triangles. And tomorrow we're going to use this to help construct the unit circle. Have a good rest of your day.